Okay, so we're going to have a look at a question. This is this comes from the 2020 HSC Standard 2 Maths paper. And this is question 33. So we're told the graph shows the number of bacteria Y at time n minutes. Initially, when n equals 0, the number of bacteria is 1,000. Find the number of bacteria at 40 minutes. Okay, so we can just read this off the graph. When time is 40, we go up to the curve, that's 4,000. So if n is equal to 40, this implies that the number of bacteria Y is equal to 4,000, and we're finding this directly from the graph. So this is from graph. And the graph very clearly passes through the point 44,000. So that's okay there. So this is part A. Now part B says the number of bacteria can be modelled by the equation y is equal to a times b to the n, where a and b are constants. Use the guess and check method to find to two decimal places an upper and lower estimate for the value of b. The upper and lower estimates must differ by 0.01. So we need to guess and check. It tells us to use the guess and check method to find the value of b. Now, if we look at this curve, we know a few points that it passes through. We know that if n is 0, that y is 1,000. And we know that if n is 40, y is 4,000. And this is very useful, because if we plug the first lot into this equation, we get 0 is equal to a times b to the 0, and then, 1,000. 1,000 is equal to a times b to the 0. b to the 0 is 1, so this tells us that a is 1,000. So immediately we've got the value of a. We also know if n is 40, y is 4,000. This implies that 4,000 is equal to 1,000 times b to the power of 40. This we can use to find lower and upper bounds of b, which are acceptable as solutions to part b. So we know that if we divide both sides by 1,000, we get 4 is equal to b to the power of 40. So now we need to try and guess and check values that will give us values of b that are suitable. Now we can sort of be a little tricky here. We could take the 40th root of 4. So it's b to the power of 40 is equal to 4. Well, let's take the 40th root of 4. So on our calculator, shift, choose root, 40th root of 4. This is 1.0352649 . So this is what my calculator tells me b is going to be. Right, so this is approximately what b is equal to. Guess and check to find to two decimal places an upper and lower estimate for the value of b. They must differ by 0.01. So what you could really do is you could pick 1.03 and 1.04. So you could say b lower is equal to 1.03, and you could say b upper is equal to 1.04, and you could just test these, right? So you could say 1.03 raised to the 40th power, 1.03 to the power of 40 is about 3.262 ... And then you could say 1.04 to the power of 40, 1.04 to the power of 40 is 4.801 ... And somewhere between these two numbers, there's going to be 4, right? So there's going to be some value between 1.03 and 1.04 that gives you the correct solution. So here we sort of didn't guess and check. We kind of cheated by calculating b by getting the calculator to do the 40th root, but you don't need to write this down, right? You can just calculate this and then you can pick values around this. And so this is now our guess and check section. And so it looks like we started by picking numbers like 1, you could pick 1.1, 2, 3, 4, 5, pick those, see which ones, between which two the answer had to be 4, something along these lines is going to be acceptable. Now in terms of the marking, you are going to get 1 mark for having y equals 4,000 from the graph for part A. For part B, you're going to get 1 mark for some working either using the equations or using guess and check, right? So because they've said guess and check, it really opens up what kinds of things they could actually be asking you to do here. The second mark will almost certainly be for having acceptable guess and check values around the correct value of b. So you'll have some working that got you to those values, something with the formulas, plugging numbers in. If you've been taught a specific guess and check methodology, the use of that would be suitable. If you haven't, just picking, like sort of calculating the number beforehand, picking values around that is usually a pretty safe way to go. So something along these lines will be the solution for question 33.